section 4 of chapter 2, we're going to be graphing quadratic functions again, but this time doing multiple transformations. I'm going to start off by doing the individual transformations. I'm going to do all of them, and then I will end this with one final equation that I will graph with multiple transformations. First, I got the equation y equals the quantity of x minus 3 quantity squared. If I have a subtraction of something next to the x inside the parentheses, that is going to let me move to the right by whatever that number is. So this is right 3. If you go right 3, that'll take you right here. This is the location of your vertex. Once you get that, since we're not doing any vertical stretch or compression, we're doing no other manipulations, it's just the parent function graph there. So I go right 1, up 1, back to the vertex, right 2, up 1, 2, 3, 4 from the vertex. Go back to the vertex and go right 3 and then up 9 from the vertex. Mirror those points because parabolas are like butterflies. They are symmetric on both sides. Do keep in mind when you're doing these, I need all of the dots that can fit on the grid. Number 2, now I have an x plus 4 inside of the parentheses. If we're adding something next to the x, that tells us movement to the left. So this is left 4. Since we're not doing any vertical stretching or compressing, it's still the same thing. From my vertex, I'm going to go right 1, up 1. Go back to the vertex, right 2, up 4. Back to the vertex, right 3, up 9. Mirror those coordinates across the center. Connect the old dots. And you're done. Number 3 in green. Now I'm dealing with a plus 5, but it's on the outside of the quadratic. It's not the part that's being squared. That tells me movement up and up and down. The 5 is going to tell me to go up 5. So we go up 5, which is right here. And then we graph the normal points. There's our quadratic. And we're done with that problem. 4, same thing. It has a subtraction of 8, meaning we're going to go down 8. This is my new location because we have gone down 8. Right 1, up 1. Right 2, up 1, 2, 3, 4. Right 3, up 9. Right 4, up 16. Mirror these dots. Make sure you're comfortable with finding these dots for all of these because that's where the majority of your points, your credit, is going to come from on these problems. That's what I look for. Does it look like the shape of a U? Is the vertex in the right location? Do you have the correct description? And are all the coordinates in the right location? So that's 25% of the problem right there. Now when we have a leading coefficient, we have a number in the very front. We don't call that slope, because these are functions that slope changes over time. That's going to affect the vertical stretching and compression. So the 3 in front of my x squared for the red equation, that's going to stretch it vertically. Stretched vertically by 3. That means it's going to take all the vertical components and triple them. Still starting at 0, 0, but normally we'd go right 1, up 1. I'm going to triple the up 1 to make it go right 1, up 3. Then I would normally go from the vertex right 2, up 4, but we got to triple that. So instead of up 4, it'd be up 12. That's off my grid, so I only got these 3 dots. This is why it's really important to recognize the shape of these functions before we get into graphing, because you might not get a whole lot of dots. Number 2, the 1/2 is going to compress it. So this is a compressed vertically. Compressed vertically by 1/2. These are going to make all the heights half of what they normally are. So it still starts at 0, 0, but instead of right 1, up 1, the up 1 is going to be cut in half to a 1/2. Instead of a right 2, up 4, it's going to be right 2, up 2, because that's half of 4. Instead of right 3, up 9, I got to cut that 9 in half and do 4.5. Normally we go right 4, up 16, but I'm only going to go up to 8. Mirror the dots to the best of your ability. And then here, is your parabola. Green one, I just want to show what a negative would do. The negative is going to flip this thing. So first the 2 is going to stretch this vertically by 2, and the negative is going to have it flipped vertically. So it's still starting at 0, but instead of up, it's going to be going down. So I'm going to go right 1, down, double what I normally do, so right down 2. And then right 2, down 8. Mirror those points. Draw the parabola. And now we're on to the very last problem in purple. For the purple one, I'm going to go left 4 because of the plus 4 inside of the parentheses. I'm going to go down 5 because the 5 we're subtracting is very, very outside. We are going to compress this thing vertically by 1/3 because of the 1/3, and the negative is going to make me flip this thing vertically. Flipped vertically. So I'm going to go left 1, 2, 3, 4, down 1, 2, 3, 4, 5. It's right here. It's going to be upside down, and I'm going to cut the heights into 1/3. So instead of right 1, down 1, it's going to go down 1/3. Right 2, it would normally go up 4, but I'm going to cut that into 1/3, which is a little bit more than 1. Right 3 normally go up 9, but I'm going to make that 3 and go down 3 instead. Mirror those coordinates. Draw my parabola. And we are now done.